In 2017, astronomers detected something that shouldn't exist. A cigar-shaped object from another star system, moving through our solar system with impossible precision. They called it Oumuamua. But from the moment it appeared, the numbers didn't add up. And what one Harvard scientist discovered has some questioning everything we thought we knew about visitors from deep space. 2 years later, another interstellar object appeared. Then the pattern became undeniable. We're not alone in the cosmic void, and these visitors might be trying to tell us something. Here's what makes Oumuamua different from anything astronomers had seen before. Most asteroids and comets are roughly spherical, shaped by billions of years of impacts. But Oumuamua was at least 10 times longer than it was wide, like a cosmic needle threading through space. What are we really looking at? When Pan-STARRS telescope in Hawaii first detected it in October 2017, astronomers immediately knew something was wrong. Its trajectory showed it wasn't bound to our solar system. It came from interstellar space and was already heading back out. But here's the catch. As Oumuamua swung around the sun, it started accelerating faster than gravity alone could explain. Dr. Robert Warwick, who discovered the object, described the acceleration as non-gravitational. Comets can speed up when ice vaporizes into jets of gas, but Oumuamua showed no signs of outgassing. No tail, no coma, just silent acceleration. Avi Loeb, Harvard's former astronomy chair and one of the world's most respected astrophysicists, looked at the data and reached a controversial conclusion. The most plausible explanation was that it was artificial, a light sail manufactured by an alien civilization. The scientific community pushed back hard. Alternative theories emerged. Maybe it was a hydrogen iceberg or an unusual fragment of a destroyed planet. But each natural explanation required objects never seen before, as Loeb noted in his peer-reviewed papers. Is this trajectory truly random? Because when you examine the precision of Oumuamua's path, the coincidences multiply. But here's what really changed everything. Oumuamua wasn't alone. 2 years later, amateur astronomer Gennady Borisov spotted another interstellar visitor. 2 I/Borisov behaved exactly like astronomers expected, outgassing, developing a tail, showing all the hallmarks of a natural comet. Let that sink in. Now we had 2 data points. One normal interstellar comet, and one that defied explanation. The contrast was striking and raised uncomfortable questions about what we might be missing. Loeb founded the Galileo Project at Harvard specifically to study such anomalous objects. His team calculated that objects like Oumuamua should be incredibly rare, perhaps 1 detection per decade with our current technology. Yet here we were, discovering multiple interstellar visitors within just a few years of developing the capability to detect them at all. The timing raises questions. As Loeb puts it, it's like getting a postcard from a neighbor you never knew existed, just as you learned how to read your mail. And yet, the astronomical establishment's response has been notably conservative. Now let me explain how the astronomical community actually handled these unprecedented discoveries. When Oumuamua was detected, initial observations were rushed. The object was already leaving the solar system, giving astronomers only weeks to study it before it faded from view forever. But here's what happened next. Rather than extensive follow-up investigations, the focus shifted to explaining away the anomalies within conventional frameworks. The European Space Agency had briefly considered a rapid response mission to study Oumuamua up close. The proposal was shelved due to technical challenges and timeline constraints. No space agency pursued interception, despite this being humanity's first confirmed interstellar visitor. Dr. Alan Fitzsimmons from Queen's University Belfast led efforts to characterize the object using ground-based telescopes. His team's analysis emphasized Oumuamua's similarity to solar system asteroids in composition, arguing against artificial origins. But Loeb documented 6 distinct anomalies that standard models couldn't adequately explain. The extreme elongated shape, the unusual tumbling motion, the lack of visible outgassing despite acceleration, the reflectivity properties, the precise trajectory timing, the rarity of such large interstellar objects. Each required never-before-seen natural explanations to account for the observations. And yet, when Loeb published his artificial origin hypothesis in astrophysical journal Letters, the response from colleagues was swift and critical, not based on data, but on the implications of the conclusion. As Loeb later wrote, "The scientific community prefers to sweep unusual findings under the rug rather than confront the possibility that our cosmic neighbors might be more interesting than we thought." Consider what we're really dealing with. Statistical models suggest interstellar objects like Oumuamua should be extremely rare, yet we detected one almost immediately after developing the capability to do so. This raises 2 possibilities. Either these objects are far more common than models predict, or our first detection was extraordinarily fortunate timing. If they're common, it suggests the galaxy is filled with debris from planetary systems, increasing the likelihood of panspermia, the transfer of life between worlds. Microorganisms could survive million-year journeys between stars, seeding life throughout the galaxy. If they're rare, then detecting one so quickly might indicate something beyond random chance. The Vera Rubin Observatory, now coming online, will dramatically increase our detection capabilities. Simulations predict dozens of interstellar objects could be discovered annually. This statistical sample will finally allow us to determine what's normal and what's truly anomalous. But the deeper issue remains. How do we investigate possibilities that challenge fundamental assumptions? Loeb's Galileo project represents one approach: dedicated observation programs specifically designed to study unexplained aerial and space phenomena without institutional bias. The project uses machine learning to analyze telescope data, looking for objects that exhibit non-natural characteristics. It's the kind of systematic investigation that wasn't done for Oumuamua due to time constraints and conventional thinking. Meanwhile, space agencies continue planning missions to study conventional comets and asteroids, but no dedicated interstellar object interceptor exists. We remain reactive rather than proactive in our approach to these visitors. When the next Oumuamua appears, and statistical models suggest it will we be prepared to study it properly? Or will institutional inertia again lead to missed opportunities? Whether Oumuamua was natural or artificial, its discovery marked a turning point in astronomy. For the first time, we confirmed that objects routinely travel between star systems, carrying information about distant worlds. The data is real. The anomalies are documented, and the questions remain unanswered. As we develop better detection capabilities and more interstellar visitors reveal themselves, we face a choice: approach these mysteries with open scientific inquiry, or continue explaining them away within comfortable frameworks. The universe is vast, full of possibilities we're only beginning to understand, and sometimes the most extraordinary explanations might also be the most accurate. Subscribe to Cosmic Void for investigations into the discoveries that challenge everything we thought we knew, because the sky was never empty, and now we finally see it. In Cosmos we trust.